Hello everyone. In today's lecture, we will look into the concept of gradient and what are the different types of gradients are there. So coming to the concept of gradient, you are all well aware of this concept of gradient in your survey. You have already studied this concept in your while studying a survey subject in your lower semesters. So let us look into what is a gradient. A gradient is nothing but change in level of a ground is called as a gradient. So if I want to formalize this statement, any departure of the track from the level is known as the grade or gradient. An up or rising gradient is one which the track rises in the direction of movement, and down or falling gradient is one when the track falls in the direction of movement. This is about gradient and rising gradient and falling gradient. When the elevation rises or when you are going to get a higher elevation, you are going to call it as a rising gradient. When you are encountering a down slope, you are going to just call it as a falling gradient. So gradients are what is the necessity to provide the gradient? Gradients are provided on the track due to the following reasons: to provide a uniform rate of rise or fall as far as possible, and to reach the various stations located at different elevations, and to reduce the cost of earthwork. These are some of. So coming to classification of gradients, gradients are basically classified into 4 different categories. How you are making this classification is a very simple method, that is the process of providing the gradient in a particular section or particular elevation. Based on the process, we have classified the gradient into 4 different categories, that is the ruling gradient, momentum gradient, pusher or helper gradient, and gradients at station yards. These are some of the classifications. Let us look into first type of classification, that is the ruling gradient. The ruling gradient on a section may be defined as the gradient which determines the maximum load that the engine can carry on the section. In other words, the maximum gradient allowed on the track sections is called as a ruling gradient. Next, moving on to our second type of gradient, the momentum gradient. Those gradients on a section. We were looking into our second type of gradient, that is momentum gradient. Here the gradient is cleared by the train with the help of the momentum gained from the previous falling gradient. So if I want to explain this, the momentum gradient are those type of gradient on a section which, though more severe than the ruling gradient, do not determine the maximum load of the train, but on account of their favorable position on the track, the train before approaching them, that is such gradients, acquires sufficient momentum to negotiate them, are known as the momentum gradient. We will move on to our next type of gradient, that is the pusher or helper gradient. This type of gradients are the important effect of the ruling gradient is its limit of locomotive capacity. That is, in the ruling gradient, we have studied that there is a certain limit of carrying capacity of a certain track. In this type of gradient, if the ruling gradient is severe, it may mean that during the larger portion of its journey, the locomotive would have its unused capacity for carrying higher loads. But if the gradient is concentrated in a specific section, such as the mountainous section, instead of limiting the train load, it may be operationally easy or even be economical to run the train on the basis of load that the engine can carry on the remaining portion of the track, and arrange for an assisting engine, that is an helper engine is provided in this case of the pusher or helper gradient for the portion where the gradient is severe. Such gradients are known as the pusher or helper gradients. Moving on to our next type of gradients in station yards. So gradients in station yards, in this station yards, what is the gradient that you need to provide for in stations? In stations, you need not provide a steeper gradients, you need not provide a higher gradients, you just have to maintain the level. That is, the gradients at station yards have to be sufficiently low due to the following reasons. to prevent the movement of standing vehicles on the track due to the effect of gravity combined with a strong wind and or a gentle push. Next, second point, to prevent the additional resistance due to gradient on the starting vehicles. That is, we have studied that at the starting portion of an engine, the resistance is more in the between the rail and the wheels. So in order to prevent that, you need to provide the lower gradients, which is about twice at the start than the vehicle in motion. However, a certain minimum gradient is required to be provided for drainage. On Indian Railways, for all the gauges, the maximum gradient permitted in the station yard is 1 in 400, while a minimum gradient of 1 in 1000 is recommended for drainage point of view. This is about gradients and classification of gradients. Thank you.